Okay, so hello everyone. I'm Rahul Baluri and I'm the event captain for Rocks and Minerals. So I'm going to be going over briefly what the event is, how it's carried out, and pretty much lots of the basic content that you're going to be wanting to know um, to be successful in this event. Okay, so to start off, I'm going to describe what the event of Rocks and Minerals is actually about. So it's essentially it's pretty straightforward based off of the title. It's the study of rocks, um, including geologic formations and Earth's lithosphere, which is pretty much all of the outer part of the Earth. So yeah, it's pretty much you're going to be looking at a lot of rocks and minerals. You're going to be having to identify them. You're going to have to be categorizing them and knowing how they're made. And what's pretty interesting about this event is that it shares a lot of kind of a basic foundation with other Earth science events within Science Olympiad. So if you are doing any other Earth science events, that could be pretty helpful since they do share a couple elements with each other. Okay, so um, to start off, I'm just going to quickly make a distinction between, I guess, rocks and minerals because they're not actually the same thing. So the difference between the two is the fact that rocks are essentially a solid formation of multiple minerals. So if you see in this diagram, granite is considered a rock, and it's composed of several different minerals, including quartz, feldspar, and biotite. Um, and in fact, these minerals can actually be broken down even further into elements. So, for example, if you look at quartz, it can be broken down into silicon and oxygen. So, in regards to elements, this event really focuses more on like a general view of rocks and minerals. So it's not really anything, really on the molecular level. Um, it's mostly, just like identifying, rocks and minerals themselves, but there are a couple aspects that go on the molecular level, which I'll be discussing later. Okay, so now I'm going to be talking about the parameters for this event. So this event is approximately 40 to 50 minutes, and it's a station event with your partner. So what this actually means is that by a station event is that you're in a room with your partner, and let's just say, I guess there are probably like 12 or so of different tables set up with different rocks and other specimens, and you're gonna have an allocated amount of time that the whoever's holding the running the event, they're going to be giving you an allocated amount of time, and you're going to have to stay within that time. And the moment they say time's up, you're going to have to quickly move to the next event. You can't stay behind. You can still change your answers in the answer sheets, but you can't linger around the previous station. So it's a really quick event. And for that reason, you're going to be wanting to budget your time and your materials and your resources with your partner because there's a lot of content and a lot of things you have to get done in a really short amount of time. So if you look at the resource folder, there's actually an event guideline sheet that pretty much shows. Sorry, 1 second. Yeah, lots of the basic topics that you're gonna have to be going over. Um, what the event's actually gonna look like. And as you can see, there are quite a few different topics. There's chemical composition, there's the rock cycle, bounds, reaction series, and whatnot. So if there's a really big variety of things to know, and I think the best way to really get an in-depth understanding of each of these is to make a Google Doc and kind of just research each of them really well, so you have a really good understanding. You could probably split topics with your partner, so you're gonna be more efficient, and yeah, you can budget your time better. So, in addition, you can also bring a couple different tools. For example, you can bring a 3-ring binder, um, in addition to a magnifying glass, because there's actually going to be specimens of rocks there that you can actually examine and look at. At least that's as far as I know. Um, oh, by the way, on the topic of actual rocks that you can touch, the screening test that's coming up on Monday at Monte Vista is actually not going to be having any, it's not going to be hands-on only because we don't have the materials necessary to do a kind of station event, so it's mostly just going to be a written test. But as far as I know, there, I might have to clarify this later on, but the actual test, based on the event sheet, I think it's actually, you're going to have actual specimens, and that's pretty much why you can bring a magnifying glass. So you can also bring a 3-ring binder. So what I recommend to put in this binder is pretty much all of the basic topics. In addition to, I think that you should probably start putting, different specific rocks and minerals in there and get, research them, each one really well. If you want to know which ones you have to look at, there's also another one. I believe this is also in the resource folder. It has the official list of all of the different rocks and minerals that you're going to have to be looking at. So, for example, there are a lot of different ones like copper and native elements, sulfides, and a huge variety. So, get to know each one of these really well, and on the day of the test, you'll be able to quickly flip to one on the day, on the station, and you're going to be doing a lot better that way. Okay. So moving on to the contents, I'm going to be talking about the difference between igneous, sedimentary, and metamorphic rocks. Now, I'm sure you probably heard of these terms a lot, probably in, like throughout science, maybe a long time ago, but now it really comes to play because these are the 3 basic types of rocks. So the difference between these 3 is that, okay, so first of all, igneous rocks, they're formed when magma cools down and it becomes solid. This essentially happens because high temperatures inside the crust of the Earth causes rocks to melt, and this substance is known as magma. And as the substance cools down slowly, mineralization takes place. And these minerals gradually increase their size until they're visible enough to be seen by the human eye. In addition to the fact that these igneous rocks are mostly formed beneath the Earth's surface. So there are 2 types of igneous rocks. For one, there are intrusive rocks, which means that they cool inside the Earth, and there are extrusive rocks which cool outside the Earth. So moving on to sedimentary rocks, these are usually formed by sedimentation of the Earth's material, and this usually happens in water bodies. So basically, these rocks are constantly weathered down and eroded until layers of sediments bind together, and they create sedimentary rocks. And lastly, there are metamorphic rocks, and these are the results of rocks being subjected to really intense heat and pressure that ultimately causes them to change their shape and form. So, this process is known as metamorphism, and it could happen. Metamorphism can happen to both igneous rocks and sedimentary rocks, and even, I guess, other metamorphic rocks as well. It's basically a result of high pressure and heat that causes rocks to change their form. So, as you can see here, I put a diagram of the rock cycle, and what this pretty much means is it kind of gives a basic diagram about how different rocks can turn into other ones. So, for example, if you see here, a sedimentary rock and an igneous rock, both of them, if they undergo heat and pressure, they can become metamorphic rocks. And there are a lot of different sources of heat. For example, there are pressures really deep inside the Earth by tectonic plate movement or continental collisions, stuff like that. They can be heated when a lot of hot molten rock, in other words, magma, intrude in the Earth's interior. So lots of stuff like that. Another note about metamorphosis, it can pretty much occur as long as it's between 300 to 700 degrees Celsius. So there are a lot of different ways that the rocks interact with each other, and that's pretty much what the rock cycle is. Okay, so moving on to the next topic. there are a lot of different groups of minerals that you're going to be wanting to know about. For example, there are silicates, carbonates, oxides, and yeah, there are a lot of more than what's here on the list, right? Right here. But here's like I guess, a brief starting list. So, what silicates are? They're pretty much minerals that contain oxygen and silicon, um, and they make up the majority of the minerals on the Earth's crust. In addition, there are also carbonates. They're created by metallic elements and the carbonate ion. So like yeah, some examples could be limestone and marble. So right down here, that is I believe calcite. So yeah, it's just an example. And there are also a couple other different examples. For example, this is a sulfate right here, which is a combination of sulfur and a couple other elements. And this is, I mean, sorry, this one. This is pyrites. And also there are just um, different minerals that are really just only one element. So this is just a gold solid mineral. So that's considered part of the native elements group. And there are also a ton of different characteristics and properties that you're going to be wanting to know in order to really identify a mineral successfully. So for one, there's luster, which is essentially the ability for a mineral to reflect light. So there are two different kinds. There is metallic and non-metallic. Metallic just meaning it's really shiny, non-metallic meaning otherwise. So yeah, this is an example. Metallic, as you can see, it reflects a lot of light. It's very shiny. Non-metallic is not so much. So that's a way to really distinguish between the luster of two minerals or rocks. And there's also color, which can be used to identify minerals. However, the only problem is that lots of minerals can have more than one color. In addition to the fact that that lots of them are completely colorless under light, under sunlight, they can change colors. So it's not really a good way to have like a definitive like identification to a rock. So there's actually a better method known as looking at the streak. And what the streak is it's basically the color of the residue and the powder that's left when you scratch a mineral over a surface. So if you look at this image right here, as you can see, both of these minerals are scratched on a surface, and they have this one has a more darker streak, and this one has a lighter streak. So the good thing about streaks is that they never change color. Yeah, like they'll always leave like a really specific streak, even though the mineral might have more than one color on the outside. So yeah, that's better than just looking at the color. In addition, hardness is also a really important mechanism to identify minerals. There's the Mohs hardness scale, which is pretty much it's how easily. It's not necessarily the hardness scale doesn't necessarily describe how easily rocks and minerals can break apart, but how easily they can be scratched. And this is described by Mohs hardness scale. This basically just rates minerals from 1 to 10, 1 being the lightest and 10 being the hardest. So yeah, basically how this works is if you scratch two minerals with each other, if they both scratch each other, they have the same hardness. If one causes a scratch, then it's the hardest. And yeah, basically you can compare minerals in that way. So for example, a mineral with a Mohs hardness scale of 1 would be talc, while one with 10 would be something like diamond. And diamond is at the top because only another diamond is capable of scratching it. So that's why, yeah, it's like pretty much the hardest mineral for that reason. Okay, next up, sorry, there's an error here. Cleavage and fracture. So yeah, don't look at number 5 because number 7 describes it more accurately because there are two different components. There's cleavage and fracture. So basically, what these two describe is how it describes how minerals break apart. So cleavage essentially describes how for example, if a mineral breaks along a really smooth, flat surface and break is really smooth and shiny, then it's said to have really good cleavage. But fracture is when minerals break unevenly and it leaves a lot more of a rough or jagged surface. So I have an image. This is an example of cleavage. This one has, this is a much more rough and jagged surface, so this would be considered cleavage. I mean, sorry, fracture. Well, this would probably be considered cleavage because it's a lot lighter. And there's also specific gravity, which is basically comparing, the density of a mineral. It compares the mass of 1 gram of the mineral to the mass of a gram of water, so it kind of helps create like a relative comparison between minerals and how dense they are. And there are a lot of other characteristics too. It doesn't really end here. For example, there are minerals can be subjected to chemical reactions. A weak acid can be used to tell if, for example, rocks or minerals contain calcium carbonate, and yeah, you can see like the reaction based on that. So yeah, it doesn't really end, with this list, but these are primarily what we should be looking for, I guess, for the events itself. So I'm going to briefly go over Bowen's reaction series, which also kind of describes it describes the cooling of rocks, the different temperatures at which different common minerals change from the liquid to solid phase. They cool off and they become solids. So it's kind of complicated to describe really briefly, but basically, just some background. There are a lot of different types of these are all igneous rocks, by the way. And there are felsic rocks, and as you can see here, felsic rocks, which are basically, they're made of feldspars and silicates, and then there's mafic, which are magnesium and iron, and basically, igneous rocks contain lots of these minerals, and these are just basically describing like the composition of each of these rocks. So yeah, basically what's going on here is that there are two different types of reactions. There's the continuous reaction, which is on the left, while the discontinuous reaction, I believe, is on the right. And yeah, this describes pretty much how different rocks and minerals cool off at at different temperatures as they're subjected to magma. Sorry, this is the discontinuous series, and this is the continuous series on the right. So yeah, it obviously goes a lot more in depth with that, so you should definitely look it up. That's a kind of like basic introduction. Okay, so here's kind of an example of a sample problem that you're going to be seeing. So, let's say you're walking from station to station, looking at one sample to the next, and you come across this sample right here. So you're probably going to be asked to identify, the name of the mineral, and based on this picture, you can kind of tell it has like a chalky white kind of soft texture. You'll probably be able to touch it, so it'll make more sense that way. But if you're able to identify its properties, you can probably tell that it's limestone, and you're going to be asked a lot of different follow-up questions about the particular sample that you're looking at. Like, for example, what type of rock is the specimen classified in? And as I mentioned before, the three different types of rocks are igneous, sedimentary, and metamorphic. And we know that limestone is part of the sedimentary category of rocks. Specifically, it's a calcium carbonate one, which kind of explains its really soft texture because there's a lot of calcium within it. And lastly, you're going to be asked a lot of really kind of random questions, kind of these random follow-up questions. They're just kind of like general knowledge. You can't really find the answer just by looking at the rock. So, for example, you might be asked what kind of what the nickname of a mineral is or what its chemical formula is. But in this case, the question's asking, this mineral is blank percent of all the rocks of its type in the world. So basically, it's saying we know that the specimen's limestone and the type is sedimentary. So the answer is 10%, but obviously you're not going to be knowing that right off the bat. But yeah, you're gonna have to kind of memorize a lot of seemingly unnecessary facts about some minerals because they actually do prove to be pretty necessary. Um, and lastly, there are a couple different resources that you can be using. The resource folder itself has some, it's kind of a little sparse at the moment, but it will be more and more filled with a lot more resources. There are a lot of different practice tests that you'll be given throughout the year. Um, and you can also go on Quizlet and kind of test your knowledge at identifying minerals. And I think one of the more important ways of identifying, getting a really good visual representation of some of these rocks is by looking at field guides, which are actual books. So, some ones that I recommend, I think, as far as I know, are like Peterson and a couple, some of the other ones that I list over here. They're really pretty helpful at getting, really in-depth looks at some rocks and learning some good facts about them. And in addition, in the resource folder, there's this really good PDF which has a lot of basic information that's really essential. So this is a great source to look at, uh, to get a good idea for the test. So yeah, it's pretty much all I really have to say for now. Feel free to ask a lot, as many questions as you'd like. You can ask me right now in the chat, or you can talk to me through the email up above. And considering the fact that screening is starting next Monday, and there's such a huge variety of different rocks and minerals that you'd have to memorize by then, you're not really expected to memorize all of them. This test is just kind of to see how far you've gotten already, which even if it isn't extremely far, that's completely okay, because besides the screening test won't really show, I guess, how dedicated you are as a member as much as interviews would. So as long as you really just develop a good set of notes by the time interviews and screening starts, and you show your best effort in developing a good list, then you'll probably be fine. So yeah, thank you for listening.